Welcome to CSIR-NET Chemistry Facts. Welcome to CSIR-NET Chemistry Facts. Today we will discuss the neighboring group participation reaction. So let's start. So guys, neighboring group participation reaction is actually a NGP type of reaction. This is the full form of this NGP is neighboring group participation. If you see these two compounds in your screen, this compound will go 10 to the power 6 time faster in SN1 reaction, okay, and than this compound. Why? Because this SN1 reaction actually depends on the stability of the carbocation. So we have to see the carbocation stability. And if you see in this case, after removing the Cl minus, the carbocation will be this one, and this carbocation will get a stability through the oxygen lone pair, and it will form this intermediate. Okay, so due to this resonating structure, this resonating stability it will get, and hence it will go faster in SN1 reaction than the second one, where the carbocation does not have any stability. So it does not have any such stability. So therefore this will go slower in SN1 reaction. But guys, this one does it NGP reaction? Can we call this reaction as a NGP reaction? No. Why no? Because this oxygen is not the neighboring group. It is actually a neighboring atom. So guys, what is the difference between a neighboring group and neighboring atom? The atom attached with the active center or the reaction center is known as the neighboring atom, and the group attached with this atom is called the neighboring group. So in this case, in the second example, you can see this undergoes faster in SN2 reaction than this one. So why it is like this? Because the sulfur present in that compound, the lone pair can attack to this carbon, and Cl minus can remove, and a intermediate can form. This is a three-membered intermediate where the sulfur has a positive charge, and this is known as the neighboring group participation. Why? Because this is a neighboring atom, this carbon is a neighboring atom, and the group attached with this atom is known as the neighboring group. So this PHS is known as the neighboring group, and this neighboring group is participating in this reaction, and hence this reaction is known as the NGP reaction. Okay, but for this case there is no such NGP will take place, okay, because there is no sulfur atom or any hetero atom will present with a lone pair to participate in the NGP reaction. So guys, here no NGP reaction will take place. Now the intermediate form in the first cases will participate in the reaction with some nucleophile, and the nucleophile attack, and it will give the final product, and this is the final product structure. And if in this case the nucleophile, suppose H2 is added, then what will happen? It will attack directly to the reactive center, and it will go for SN2 type of reaction, and we will get this product. And for NGP we will always get a faster reaction rate. The reaction rate is fast for NGP and slow for non-NGP. So why it is? This is the reaction coordinate, this is the potential energy, this is the reactant, this is the product, this is the transition state, and this is the activation energy in this curve. So this activation energy is known as the EA, and this is for a normal reaction. Okay, so this curve is for normal reaction. Now for NGP, this is the curve where an intermediate will form. This I is the intermediate, and this intermediate leads to the product, and this is the activation energy of the formation of the intermediate, that is the EA1, and this is the formation of the product, this is the EA2. So there are two activation energies are present, and these both are very smaller compared to the average value of this both is lesser than this EA. So guys, what will happen? The average value of this EA1 and EA2 is actually lesser than the EA itself, and hence in case of the NGP reaction, for a NGP reaction, the activation energy will decrease. So what is the relationship of the activation energy and the rate of the reaction? So for that, for finding that, first we know the Arrhenius equation, and the Arrhenius equation is actually relating the rate constant K with the activation energy. K equal to A into e to the power minus EA by RT, where A equal to the Arrhenius constant, and this is another equation, del G equal to minus RT ln K. So guys, from the first equation we know we can get this one, ln K is equal to ln A minus EA by RT. So guys, from this equation we can conclude if EA will decrease, then ln K will obviously increase. And if ln K will increase, then from this equation we can say the mod value of the del G also will increase. So guys, the mod value of the del G will increase means the negative value of del G will increase, and that will give the reaction more spontaneous way. Okay, so that reaction will be more spontaneous, and therefore the reaction will be more faster. So this will be faster reaction. So therefore the NGP reaction is actually a faster reaction, okay, compared to the normal reaction. So guys, now we can see this example. This will go faster with the acetic acid reaction, and this will go slower in acetic acid reaction. Why? If you see the structure, then you can see this is the board conformation of this structure, where the OAC are in the plane and this OTS are in the below the plane, and both are in equatorial. And this is the stable form of this compound, and this is a trans geometry. And if it will flip, if the ring will flip, then it will form a board conformation, a chair conformation. So this previously also it is chair conformation, where the OTS, both OTS and OAC will go in the axial position. So this is the OAC OCOCH3, and here you can see CH3 can donates its electron to the antibonding orbital of this CO bond of OTS, and a NGP will take place where the OTS minus will remove. So guys, this is, you can see this is the sigma star orbital of the carbon oxygen bond of COTS, and in the sigma star orbital the electron come from the oxygen, and therefore OTS minus will remove, and it will produce this one. So this is a intermediate will form, and here you can see this intermediate is actually equivalent with this. So both the groups are in the above the plane, and this is the intermediate, and this oxygen can come here and the double bond can open, and it can give a equivalent resonating structure, and due to this resonance this intermediate is quite stable. And here this both are the equivalent resonating structure, and it is quite stable. So guys, this intermediate will form which can stabilize by the resonating structure. Now what will happen? This HOAC, that means acetic acid, whatever is there in this reaction medium, that lone pair on the oxygen of this acetic acid will attack from the equatorial side, and this will open, and we will get a compound where in this chair form we can see this will go in the axial bond, and this will OAC will come in the axial bond. So guys, so this attack happened from the axial side. Okay, so this is the OAC and this is the OAC. After ring flipping we can see that both will come in the equatorial bond, and hence the geometry is actually equivalent with this. One will go in the above the plane and another will go to the below the plane. So this is trans geometry, And in this case, this NGP will take place, that is a SN2 type of reaction, intramolecular SN2, and this is another SN2 will take place. So therefore 2 SN2 will take place, that means 2 sequential SN2 will take place in case of this reaction, okay, and the NGP will take place. For this compound, so this is a cis conformation, here the OTS will be in the axial and the OSC will be in the equatorial, and this is a sigma star orbital, and this is the OSC. If we write the OSC, the full form is double bond O CH3. Now this oxygen lone pair is far from this sigma star orbital, and hence it cannot attack in that orbital, and hence there will be no NGP can take place. Okay, let's see if the ring will flip, then it can attack or not. So if the ring will flip, then the axial OTS will come to the equatorial OTS, and the axial equatorial OSC will come to the axial OSC, and this is a sigma star orbital of the COTS bond. And now the electron cannot come from the oxygen, because in this case also it is so far, and hence no NGP can take place in this case in both the conformation. So both the chair conformation, the NGP cannot take place. So guys, in this case what will happen? So this is the chair conformation. Here you can see that the OTS will be there in the axial and OS will be in equatorial. As there is no NGP, therefore directly this HOAC means that oxygen lone pair will give the electron to the antibonding orbital of the OTS in SN2 manner, and the OTS minus will remove, and it will form this compound, right? So as the OTS in the axial bond, therefore HOAC will attack from the equatorial side, so therefore it will go for the equatorial bond, and one OAC in the above and one OAC in the below, so therefore trans product we will get. So in both cases we will get the same product, but in this case no NGP is take place, so therefore it is a slower reaction, and this is a faster reaction. So therefore NGP is always faster than the non-NGP step. So guys, hope you understand this mechanism. Thank you so much for watching this video. Please like, comment and subscribe this YouTube channel. I will come for the next video tomorrow. Thank you so much.